we've been working with vectors. We're continuing to work with vectors today. Today we're going to come up with something called the dot product. The dot product is actually used in math in a lot of different ways. If you've ever talked about matrices before, you might have talked about dot products before. It's just a way of taking multiple numbers. And so when we think about a vector, there's an x component and a y component. We're going to take two vectors, so there's 4 components, and we're going to multiply and combine them together to get a single number in the end. Okay, they're going to get a one-numbered thing in the end. It doesn't have any direction anymore. It's just a number. And that number at times won't make a lot of sense, but at other times it will tell you angles, which is what we're trying to get from today. So here's what we're doing. We're just starting off with understanding how to do the dot product. To find the multiplication of two vectors, if I want to take v times w, to take v times w, you are going to take the x components of both vectors and multiply them together. And you're going to take the y components of both vectors and you're going to multiply them together. And then you're going to add those numbers to get a dot product. So for example, looking at number 1, you are taking the x components of both vectors. So the v x value is 1 times the w x value is 2. Those are my two x components. I'm going to add to that the y components of each number. So -6 and 2. 1 times 2 is 2 plus -12. I get -10. That is the dot product. Right now it doesn't mean a whole lot to you, but you found the value. Make sense on what we did with that? V times v. Find the dot product of v times v. If I took v times v, we're taking the v component of 1 and multiplying it by 1. I'm going to add to that the y component of v, so that'd be -6 times -6. I'm going to get 1 plus 36. I get 37. That is the dot product. Understand what we're doing with that one? Find the magnitude of v real quick. Find the magnitude of v. We've been doing that the last couple days. It's not a lot different. If we're finding the magnitude of v, you've got your x and y components, that 1 and that -6. If I'm finding the magnitude, I'm just doing Pythagorean theorem. And so I'm taking 1 squared plus -6 squared. It's 1 plus 36. It's 37, and I need to square root that whole answer. That is the magnitude. It is very similar to what we did when we found v times v. When we found the dot product of this thing. So understand that dot product and magnitude have some combinations here. What do you think w times v was if v times w was -10? -10. The properties that we talk about with multiplication, 2 times 3 is 3 times 2. Same thing is true here with dot products. Find these two things. Find D and F really quickly. Know that once you find D, F should be a lot easier. I'm going to give you like 20 seconds. Go. I don't know. Campbell, what'd you do to find W times W here? 2 times 2 plus 2 times 2. What'd you get for your dot product? 8. If 8 was your dot product when you took W times W, what did you find for your magnitude? Yeah, square root of 8, which is 2 radical 2. Those two things are combined. They're the same. They're very similar. Questions with dot product? They don't do a whole lot for you yet, but they can. And so since the dot product of two vectors is a real number, we sometimes refer to this as a scalar product. Scalar is a fancy word for a real number. Okay, it's just a number. It doesn't have direction, and so it's a little bit different than vectors, but it's just a number that doesn't have a direction with it. One use of dot product is to calculate the angle between two vectors. This is what we're trying to find out here. This is the formula for the day. This is the toughest thing we'll adjust with. It's this. Cosine of theta is equal to the dot product of u times v. So if you take two vectors and you multiply them together and then divide by their magnitudes, it will tell you the angle between the two vectors. So let's put this into practice. Let's look at letter A. 5i plus 2j. And v is equal to -i minus 8j. And so the first thing we're going to do is we're trying to set up this guy. And so the first thing I need to do is find the dot product. I'm going to take u times v. So, Garrett, what am I going to do to find u times v? Five and negative 1, so he's multiplying his x components. 5 times negative 1. Yep, plus. Yep, 2 times negative 8. So it's negative 5 minus 16. His dot product is negative 21. Cool, we need a dot product. In order to find this problem, not only do we need dot product, but we also need the magnitude. So we're going to do magnitude here pretty quickly because you guys are smart. To find the magnitude, we take 5 squared plus 2 squared. 25 plus 4. This guy is the square root of 29. And if I wanted to find the magnitude of v, it would be 1 squared plus 8 squared. I don't care about the negatives because when I square it, it's positive anyways. 1 plus 64 is the square root of 65. Those are the 3 things I need. Once I have those 3 things, I can plug back into my equation and solve. And so I'm trying to solve this equation. Cosine of theta is equal to the dot product over the 2 magnitudes, square root of 29 and square root of 65. What am I going to have to do here to get theta by itself? Inverse cosine. So make sure your calculator's in degrees because we are doing degrees for this chapter. And so I'm going to show you some tricks here that make this easier for me to type in. So I'm going to start off by hitting second cosine. So I'm doing inverse cosine of that weird number. It is a weird looking fraction. And so to make life easier on myself, I hate when there's like 10,000 parentheses. I'm going to use the fraction button on my calculator. So if you hit alpha, which is the green button, and then F1, so the top left-hand corner, the first choice right there is n over d, and it's going to allow me to type this thing in as a fraction. That way I can type it in exactly the way we are doing here. So I'm going to type this in. Negative 21 goes on top. On bottom, I'm going square root of, what was our first one? Square root of 29, sorry. Square root of 29, hit the over button, and now I'm going to do square root of 65. You don't have to type it in this way. You can type it in with parentheses all day long, but it just makes it look prettier. It makes me understand that I typed it in correctly. I hit enter. There is my answer, 118.926 degrees. That is the answer to this question. Let me show you what we just found, okay? Let's draw a picture of this really quickly. If I were to graph u, I'm going to pick this spot right here. If I were to graph u, I would go over 5, 1, 2, 3, 4, 5, and up 2. It is that vector right there. If I were to graph v, I'm going left 1 and down 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That would be this vector right there. We just got this answer. Does it look like the angle between those two things is around 118 degrees? That's what we just found. We used our vectors and our dot products to set that up to find the difference between the two. Try letter B. Get an answer for that. Good. V times W. So we're taking 1 times 1 plus square root of 3 times negative 1. And so on top, my dot product is 1 minus radical 3. If I find the absolute or the magnitude of V, what's the magnitude of V? 2, right? Yeah. The magnitude of W is square root of 2. And so when I set this up, it is cosine of theta is equal to 1 minus square root of 3 all over 2 radical 2 on bottom. We're going to type that in. So again, we're going second cosine. On top, I'm going to go alpha F1. I want to type this in as a fraction just to make my life easier. 1 minus square root of 3 on top. On bottom, it's 2 square root of 2. I type that whole thing in. I hit enter. It's going to get me an answer of 105 degrees. The difference between those two angles is 105 degrees. If you graphed out the two vectors, you would get to that point. Questions on the front side? The good news is that is by far the hardest thing. The back side is crazy easy, so flip to the back side. On the back side, we've already done the hard part. And so given two vectors, you can find the angle doing what we just did. But there are two things that could happen with our vectors. Our vectors could be parallel or they could be perpendicular. And so those two concepts we're going to be able to find at a faster pace. two vectors, v and w, are said to be parallel if there is a non-zero scalar, alpha, so that v is equal to alpha w. In this case, the angle theta between v and w is, what would the angle be between two lines if they're parallel? 0 degrees, but not just 0 degrees. The difference could also be 180 degrees. All of our answers are going to be between 0 and pi, by the way. And so think about what that means. If you had these two lines are parallel. What are their angles? They're exactly the same. There is no difference between their angles. This would be 180 degree difference. It's the direction that they're going. One is going positive, one is going negative. That would give you a difference in between those two things. 3i minus j and negative 12j plus 4j. You could do the thing we did on the front side. We could find the angle. All right, but there is something special that happens with parallel vectors. I'm going to write them out in the other form because I hate the complex form here. So 3, negative 1, and negative 12, and 4. Those are my two vectors. Here's what this alpha part meant, the non-scalar alpha. That's a weird thing to say, but here's what it means. Is there some number that I could multiply that top vector by, like distributed it in, that would get you the exact same answer as the vector on bottom? Negative 4. Would you agree with that? If I multiplied this top part with negative 4, I get the vector negative 12, positive 4. Yeah, they're the same. Here's what you need to show that they're parallel. You need to show that negative 4 v is exactly the same as w. If you can multiply by some non-zero scalar and be equal to each other, then they're going to be parallel. So these two things are parallel. We could also do what we did on the front side and find that their angle was different, okay, that their angles were 0 or 180. We could graph it out as well. Let's graph out this vector real quick. 3i minus j. So I'm going to pick a spot. I'm going 3 to the right. 1, 2, 3, and down 1. That is vector v. And then I'm going to graph vector w. So I'm going to start over here and go. I'm going to start here because I got to go to the right a little bit. I'm going to start there. I need to go to the left 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I would go up 4, 1, 2, 3, 4. Oh, I can't draw straight lines. Do those two lines look parallel? It's because they are. What's the difference between the two angles? What's the angle difference? 180 degrees because one is going one direction, one's going the other direction. If the angle, so that's parallel. If the angle between two non-zero vectors is pi over 2, or what angle is that in degrees? 90 degrees. The vectors are called perpendicular, but we're not going to write that on the line. Perpendicular is a word that means two angles have a 90-degree difference. You could also use the word orthogonal. Why do they use another word? Because they can, but it's fun to say. Orthogonal. All right? Orthogonal vectors. This is really easy. Two things are said to be perpendicular or orthogonal if v times w, or in other words, the dot product is 0. If the dot product is 0, they're perpendicular to each other. So if I found v times w down here, they would be perpendicular. I don't know. V times w, we're trying to find the dot product, so I would take 4 times negative 3. The x's multiplied together, add to that negative 6 times negative 2. This is negative 12. That is positive 12. I add those together, it gets me 0. Dot product is 0. Therefore, orthogonal. They're perpendicular. You could graph them and see that, or find that the difference between their angles are 90 degrees.